So welcome to Calculus 1. This is just an online course I'm putting together to teach some of the basics of calculus. So here's a brief course outline of the topics we'll be covering. So we'll be starting with average rate of change, going to instantaneous rate of change, which is involving derivatives, and then we'll go through all the properties of the derivatives. But we will not be covering trigonometry in this, at least until further down the road. We're just going to stick with power property, exponential functions, logarithmic functions, chain rule. Well, that's, so yeah, we'll be just covering those types of functions, not trigonometry. And so these are just the topics we'll be covering. So I guess we'll start with topic 1, which is average rate of change. So the average rate of change is the change between 2 points. So let's say we have a circle, and on the circle we have 2 points, point A and point B. Average rate of change will show the change between those 2 points. So that is referred to as a secant line because there are 2 points. It's the change between A and B. Now this is not involved in average rate of change, but for the next lesson when we get involved with instantaneous rate of change, we will be talking about tangent lines. So that is where you have 1 point and a line that goes, oh, I don't know why I did that. Let me well, it's just 1 point on the circle. So let me redraw. So where you have that and just one line going through it, it's a bad drawing, that's referred to as a tangent line. So the tangent line is for instantaneous rate of change, and the secant is for average rate of change. So back to average rate of change though. In general, if y is a function of x, so y equals f of x, then the average rate of change of y between x equals a and x equals b is f of b minus f of a over b minus a. So it's basically the change in y over the change in x. So if you recall from an algebra course you took, or I don't know what class it's in, when you're finding linear functions, when you're finding the slope of a linear function, you use change in y over change in x. So this is what we're finding. We're finding the slope of the secant line. So for our first example, we have a function, x squared minus 5x, and we want to find the average rate of change between the point x equals negative 2 and x equals 2. So we'll label this as point A and this as point B. Now, what we can do is we can do this graphically or just analytically. We'll start doing with it analytically. So we first need to find f of negative 2. So that equals negative 2 squared minus 5 times negative 2. Negative 2 squared is 4. So 4 minus 10, so 5 times negative 2 is negative 10, but that turns into a plus. So that is 14. And then f of 2 equals 2 squared minus 5 times 2, which equals 4 minus 10, which is negative 6. So then from here, to finish the analytical example, you would take, so going back up to the general form, you would take and then that's A, and that's B. So f of B, which is -6, minus f of A, which is 14, divided by B minus A, and then you just calculate that out. So -6 minus 14 is -20, divided by 2 minus a -2, which is just plus, so that's 4. So that gets us -20 divided by 4, which is -5. So that is the average rate of change between the 2 points. Now to show a graphical representation of what we just found, here's the coordinate plane over here. So we have 2 points already, but I'm just going to sketch the function, the entire function. So -2 is 14. So I'm going to change the scale. So if we need to go up to 14, 2, 4, 6, 8, 10, 12, 14. So these will be counting by 2s. So 2, 4, 6, 8, 10, 12, 14. And then this is fine because that's 1, 2, 3, 4, 5, 6. So that's fine there. Okay, so we'll plot -2, 14, -2, 14, and then 2, -6. And then to find some other points, I'm just going to look at my calculator here, so give me a minute. So -1, 6, 0, 0, 2, -6, which we already have. Then we have 4, 1, 2, 3, 4, -4. So let me just so it basically, it's going to look kind of weird because of the scale. I made that's really bad drawing. Scale, I made the y-axis, so it looks kind of distorted, but it is just a basic parabola. So then to show the rate of change between these 2 points, you would go to x -2 and then 2, which is down here. So that's really kind of hard to see because the drawing's bad, but the slope of that red line, basically, what this means is the slope of that red line is -5. So there's just a problem showing the average rate of change for this function here between point A and point B. If you have any questions about average rate of change, feel free to leave a comment in the video. Otherwise, go ahead and go on to lesson 2, which will be on estimating the instantaneous rate of change.